So we're going to kind of start from the beginning with like what sine and cosine look like, what are their qualities, and then we're going to do some problems where we have to find the different properties of some graphs. All right, so really only two slides, but we're going to pack it full of information. So let's first start with the sine of x. What does that look like? Draw a graph what it looks like here, and then we'll identify all the properties. I need to do this real quick. Sometimes it messes up. Sometimes that goes off for whatever reason. All right, so what does the sine graph look like? It starts here at 0, it goes up, then it goes down, and then it just kind of keeps on going that pattern. And same in the negative direction, it goes down, it goes up, and then it just kind of keeps on going. So that's what the graph looks like. All right, so the first thing is, what would the domain of this be?
You good on here?
Yeah. Good, all real numbers, negative infinity, positive infinity, we're good. It's going to go up and down, up and down, up and down, up and down, all the way to positive infinity, and up and down, up and down, up and down, all the way to negative infinity. No matter what we add to this sine function, it will always be negative infinity, positive infinity. All right, now the range could change if we add some numbers to it, modify a little bit. But just for the parent function, the sine, anybody remember how high it goes and how low it goes? It goes up to 1, so kind of what you would think. It goes up to 1, which if you think about the unit circle, the maximum, like the highest y coordinate, number times the y is 1. And then the lowest is negative 1. So the domain, it kind of stays in between that range there. Sorry, the range is negative 1 to 1. Now we can modify that, we could add numbers and it'll change the range, but just for the parent function, it goes up to 1, touches it, and down to negative 1, touches it, so we use the brackets. All right, next one, see if you can figure this one out. The sine function is symmetric about what axis? Can you tell? So symmetric about the y would mean if you flip this over, it would match exactly. What's that word? All right, thanks for that. If we flip it down, it should match exactly.
The origin.
Origin, right? Yeah. Right. Because the origin is like kind of both. You do both. You flip it over and then down, and then it'll work, right? Or flip it down and then over, it works. So it's symmetric about the origin. All right. Next thing. So if anybody remembers this. So we said that the sine function is periodic. Periodic just means it repeats itself over and over and over again. All right. And then how long is each period? Yep. Yeah, good. 2π. So right here, the end of it, what we start is 2π. So one period it would be up 1, down -1, and back up to 0. So it would be like one period. Again, so each period 2π. Okay, the x-intercepts. See? So x-intercepts work across the x-axis, so we have one here, one here, one here, so one here. This would actually continue to go on forever and ever. If we were just talking about the first period, it would be these, 0, pi over 2. Anybody know what this, what do you think this one would be here? Yeah, this one pi, right? It's pi. So the intercepts would be at 0, 1 pi, 2 pi. This would continue to go 3 pi, 4 pi, 5 pi. So how we're going to write this is that the intercepts, x-intercepts are at n pi. Okay, n is going to be an integer. So we say n pi where n is an integer. That's the way of saying that it's every multiple of pi. So same with negative 1 pi, negative 2 pi, negative 3 pi, negative 4 pi. Any integer, which is positive and negative whole numbers, times pi would be the intercepts. So n pi. This also has a maximum, which we kind of stated with the range. The highest it goes up to is 1. This also would repeat a lot of times, but we'll just say for the first period, it reaches 1 there at, what do you guys think is 1? If you think about the unit circle, where is the y coordinate 1? Pi over 2, right? Pi over 2 in the unit circle, the y is 1. So remember, this is kind of just like the unit circle, sort of just plotted. All the y values of the unit circle just plotted. And then, that's going to be at pi over 2. We also have the minimum value, which is negative 1. So the minimum, the lowest it goes is negative 1. And that's going to be at 3 pi over 2. So we kind of think of this graph as being divided like into fours. So we have this section from 0 to pi over 2 goes up to 1. So at 1 there, and 1 is at pi over 2. And then it goes down to 0. So at pi we have 0. And then it goes down to negative 1. And pi is 3 pi over 2. And it goes back up to 0 from 3 pi over 2. There are like 4 different pieces. Well, and this is at 3 pi over 2. Just a couple more things. Something we're going to look at a lot today is called the midline. This kind of is self-descriptive. What would you say the midline of science is? 0, yeah. The middle of it, the line in the middle, it's just an invisible line, but you can think of it as like a dotted line that goes through the middle. So it's an equation of y equals 0. So there's not actually a line there, but it's just an invisible line. Kind of like an asymptote would be. Sort of just divides the function in half. Right. And then another thing that we did mention before, which was amplitude. The last thing for this one. Amplitude is the height. Remember from last Thursday. Amplitude is the height it's the height from the midline. So we're going to start at the midline to the top or the midline to the bottom. So that's defined as the amplitude. It's from the middle to the top or the middle to the bottom. Midline to top or bottom. It's not the overall height, it's from the middle to the top, middle to the bottom. It's always going to be a positive number because you can't have a negative height. It can be like negative 3 feet tall. Right? So always be positive. So with our parent function here, the amplitude is 1. So it's from the middle to the top and the middle to the bottom is 1. So we say A equals 1. And that's about all you could say about with the parent function there and the sign. All right, so let's do the same thing with cosine. Here, let's go ahead and graph cosine. It's almost identical. just shift it over. It has what's called a phase shift. And instead of starting at 0, it's going to start at the top. It goes down, then it goes up. It goes down. So it's like that. And then like one period, what we're typically using that will be from here at 0 back up to here. Like from peak to peak. That's one period of the cycle. So it's more of kind of a U-ish shape or like a cursive U or cursive V. But it's the same thing, it's actually just shifted over a little bit. Because if I were to take this whole graph and just shift it over here, shift it more that way. And then just connect with it. So it'll be the same thing. Alright, so domain is going to be the same because it still goes forever. It's periodic, so it goes forever. So domain is going to be all reals or negative infinity to positive infinity. A range, it hits the same numbers, it goes down from -1 up to +1. This down here is -1, +1. So range is the same, brackets -1 to +1 bracket. Think about for a second which one this would be symmetric about. So what axis? Yeah, the wax. Yep. Y is here. Flip it over when you match up exactly. It is symmetric about the Y. Okay, the period of this is actually the same. It's periodic, and each period is 2 pi as well. This thing's out here, 2 pi. If it was like a tangent, that's really where it would change, but I'm not really going to talk about tangents right now. But a tangent has a period of 1 pi. The intercepts, similar idea here that they keep repeating, so it might be a little bit more challenging to write it. So here's where it crosses, here's where it crosses. It's like 1/4 of the way, which is pi over 2. This is pi. 3 pi over 2, so it's sort of the same markers there. So it crosses at 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, -1 pi over 2, -3 pi over 2. So a similar idea, we're going to say n, but instead of saying n pi, we're going to say n times pi over 2. So n pi over 2. Where n is a, how do you think we should say this time? It's not just an integer. So that would have to be 1 pi over 2, 2 pi over 2, 3 pi over 2. How can we modify that? What type of integers does it work for? Well, it has positive and negatives, but not all positives. No. 1 pi over 2, 3 pi over 2, 5 pi over 2, 7. Yeah, odd numbers, right? Where n is an odd integer. So that includes positive and negative odd numbers. Okay, the minimum and maximums are the same. So the max is 1 again. It occurs here at 0 and also 2 pi. really every multiple of 2 pi. The minimum down there is at pi. The minimum is still -1. Pi. The last 2 things which we're going to look at here are the midline. Midline is the same, goes right through at 0. And amplitude is also the same. So the amplitude from midline top is still a distance of 1 and the bottom. So that's the parent. That's all you really got to write down. So the assignment we're going to do is it's really a delta math assignment. But don't start it yet. You'll have plenty of time to do it. I'm going to show you some stuff here quick. So the first thing that you're going to do on these delta maths is to find the midline. We're going to be finding midline, amplitude, and period. So the midline just said it goes right through the middle of the graph. This is a cosine function, but it's been shifted up a little bit. You can tell it's cosine because it starts at the top. So the midline is going to go right through here, which is pretty easy to see on this one. Right, the midline will be at 1, so we type it in as an equation. Y equals 1. Right. Sometimes it's not as obvious. That one's pretty obvious. Find that one that's not quite so obvious here. All right, like this one. So it'll take a little bit more work to identify where the midline is on this one. If you had to guess, where would you guys guess it is? Yeah, you might guess -2. Maybe you guess 2.5, or I don't know. It is -2. There is another formula of how you can find this other than just eyeballing it. So another formula, if you're struggling with identifying it, that you can do is you take the top number, the highest one, which is 1, and the lowest one, which is -5. You add them together and divide by 2. And 1 plus the -5 divided by 2. So your biggest plus your smallest, you're like picking the average of the 2. It would be -4/2, which is -2. So as midline, if you wanted to write down a formula, really it's written like this: a plus b over 2. Just the average, something is the highest, plus the lowest. Another way to find the midline. But again, it's not difficult. These problems are pretty easy. The next one is the amplitude. So the amplitude, the easiest way to find that is to find the midline actually first. So on this particular one, the midline is here at -1. And then the amplitude is the distance from the midline to the top or the midline to the bottom. It's just for like half of the overall height. Half the height. So here it goes up 1, 2, and it goes also down 1, 2. So the amplitude is 2. This is the distance from the middle to the top or the middle to the bottom. You just have to type in a number for that. So you'll just type in 2. So middle to the top or middle to the bottom. So like this one is just an amplitude of 1. The middle is here, and it's just up 1, also down 1, so just 1. And the last one, some of these can be a bit tricky. The period. So in the period, you need to figure out basically how long one cycle is. So I always start where it crosses the y-axis here. And then this is a sine function. It goes up, down, and then where it's even with that again, where it reaches the same spot, that's one cycle. So that's the period would be 1 pi. Because that's how far we went the x direction, 1 pi. So let's take pi. Do one more of those. This one's a cosine, just starting at the top. So it completes one cosine here and back up. So the distance there, the x thing would be from 0 to 4 pi. So 4 pi is what you do. So go ahead and